What if Earth's surface was perfectly smooth?
We should probably clarify exactly what that means, right?
Yeah, so we were going to use the word flat, and then we just really didn't want people to think that we meant the Earth is flat.
Yeah, that has the wrong implications.
Connotations here.
So the Earth is still a ball. In fact, it's even still an oblate spheroid.
Mm-hmm.
But there's no elevation change on land. We were going to do it originally that all the elevation was the same across the whole world, but apparently it turns out that buries the entire planet in like 2.5 kilometers of water.
Yeah.
Yeah, that just means the entire world is ocean.
Which we might do someday, but we're not doing it.
Just a different hypothetical question, but...
We didn't want to cover that right now.
Right.
Yeah, we're not doing that one now. So what we did is we decided all the land that is existing is flat, and I think we said, was it like 10 feet above sea level, or just...
Something like that. Some like random elevation above sea level.
I think 10 feet is what we had in mind. Just where it's like, you're not going to be, underwater in high tide, but...
Right.
Yeah.
Yeah, so all the land is flat.
No mountains, no valleys.
No mountains, no valleys. Everything's just kind of at, 10 elevation all the way across the whole, all the land.
It also doesn't mean that, like, there's no friction. There's still friction. All the ground still has its same, like, texture and consistency, but it's just smooth.
Mm-hmm.
Yep.
I don't know. There's probably a better way to word it.
Everything is Iowa.
Yeah, everything is Iowa. What if everything was Iowa? Is the other way you can phrase this question?
I hope Iowa is actually as flat as I think it is. I'm pretty sure it's one of those really flat ones, right? It's a flat state.
Maybe. I don't know.
How flat is Iowa? Iowa is generally not flat.
Shit. Okay, well, sorry, Iowans. Pick a different state that is flat. Kansas? Is Kansas flat? I feel like Kansas would be flat.
I literally have no idea.
I'm just going to drag all the states until I find a flat one.
By any measure, Florida takes the prize for the flattest state in the nation.
What? That makes sense,
Really?
actually.
It's all beach. There's not enough of Florida to go high.
Right. It's a long, skinny state, and it's beach on both sides, so...
When you think flat, you think Midwest, though.
Yeah.
I'll make this comment, though. Florida, the highest point in Florida is 345 feet above sea level. So even in the flattest state that you can imagine, there is 345 feet of elevation change. That's no longer there.
There you go.
So, that's the setup. I think we covered all the parameters.
Mm-hmm.
Yeah, I think we did.
Which leaves us with Chris. You're going first.
Yes, I will go first. So for my answer, I wanted to look at, like, water and specifically rain, what happens to rain. So right now, in our world, when it rains, it drains into rivers, and then rivers drain into the oceans, and that's, like, how water works.
Yeah, it flows downhill.
Yeah, it flows downhill because of gravity. That doesn't necessarily happen in our case. So first I want to just look at, like, the importance of mountains in general for water. So people tend to call mountains, like, the water towers of nature. So, like, it stores water in the form of, like, snow and ice, and then when it warms up, it slowly melts and it distributes it to, like, ecosystems below through the rivers. And pretty much all major rivers originate from mountains. So it's like, what happens if we don't have any mountains? We don't have that natural distribution system.
Right, where does the water go after it rains?
Right. Does no one have, like, water anymore? That was, like, my first instinct when I heard this question. And the answer is actually no. So mountains, like, if you're in a specific spot and there's a mountain between you and the ocean, what happens is what's called a rain shadow, where the water from the ocean evaporates, it condenses into a cloud, goes to the mountain, and the mountain sort of forces the rain to precipitate, and all that rain is concentrated onto the windward side of that mountain. And then that water goes, it, like, flows down on that side of the mountain. But on the other side of the mountain, the leeward side, all the air on that side is completely dry. So it blocks out the rain, and what happens is the desert forms. So that's kind of why deserts exist, is because mountains are there. So if there are no mountains, then instead of all the rainwater concentrating in one area and then distributing that way, it's just going to distribute, like, naturally and, like, more evenly. So all deserts are going to go away, or a lot of deserts. I don't know if all of them, but...
Yeah, I looked into it. Apparently, so the Sahara, for example, is a unique case in where the reason the Sahara is so dry is more that it's on the equator, and it's in this band where it's getting so much direct sunlight that's, like, not angled or anything, which makes it more intense, that it's just, like, actually dries out that way, so that doesn't precipitate there very much.
I know there's also something with the winds where like there's bands of winds above and below the equator, but then it's almost like more of a dead zone in the middle, or maybe it's not actually exactly the equator, but there's like a space between like the main like trade winds that has less wind coverage, which makes it dry out more or something. I don't remember exactly how it works. But
it's good that we all researched why the Sahara Desert is there, but none of
Yes.
us actually came to a real conclusion.
Exactly.
Yeah. So yeah, there are areas like that exist. So there'll still be deserts, but like in the U.S.,
It would be very
not near the
uniform.
equator. Yeah, there won't be that many deserts. I actually looked at like a climatology map of the US because I wasn't sure if like the rain would reach the middle of the country as much as the ends, but it does pretty much. Like the US, the only reason why it's dry at all is because of the mountains on the left, but then on the right side and like near towards the middle there is still rain, so it will distribute. So what happens when the rain actually lands and hits the ground? My first instinct was to say that it was just going to stay there because there's no slope, so it's not going to drain into a river or anything. But it's not just going to stay there. It's actually going to, because soil and the ground, they're all permeable. So the water is going to get absorbed into the ground. And then underneath the ground, there are actually like pressure differences based on the types of soil, because the soil isn't really uniform. So there's a flow underground, and that's how it can like even out and get to where it needs to go.
Oh, interesting.
So there are different classifications of soil, I guess, underneath. They range based on the permeability of the soil. So it goes from aquifers, which are highly permeable. Then there are aquatards, which are partly permeable, like sandy clay was the example they gave. Aquicludes, which are porous but impermeable. So they have like little pores in them, but they don't actually let water through.
Such a tease.
Yeah, I know.
It's like my pores are open. Just kidding. Blocked.
Yeah, so the water basically just gets trapped in the pores and it doesn't go through. And then there are aquafuges, which are non-porous and not permeable. And the example they gave for that was granite. So there are actually cases underwater where like there can be a slab of granite just in the middle of the ground, and it holds the water in like that spot, and that's like its own contained aquifer. So I wanted to look specifically at granite because there are a lot of places on the world where like granite is above ground, and if water doesn't get absorbed into there, I want to be like, what happens if it rains on that area, because it's perfectly level. So to look at this, I had to look at a property called wettability, which is basically just the property of when water goes onto a material, how much that water spreads out or how much it beads up.
Wettability is such an incredible term.
That's such a
Yeah.
that's like
It's
such a
it's
made up
fucking
word.
like Budweiser ad campaign word. Like,
Yeah, exactly. It's like it's gonna be like the tagline of the next Bounty product.
right.
Yeah.
Our paper towels give you maximum wettability for minimum cost.
Super wettable.
Oh, it sounds dirty when you say it that way.
Yeah, it does.
All right. Anyway.
Anyway, yeah, wettability is measured through the contact angle, which means it's like at the interference of the solid, liquid, and gas. So in the case of water on a surface, the surface is the solid, the water is the liquid, and then the air is the gas. So the angle that it's kind of hard to describe without a diagram, but it's just at the interface if it's like bulged out or inclined inward, the edge of the drop. So impermeable doesn't necessarily mean that it's going to bead up like a circular drop. It could spread out if it has high wetting properties.
Let me try to wrap my around that. So if the rain comes on something, if the rain comes on it and it's permeable, you need to know how wettable it is.
So if an object has high wettability but it's impermeable, then the drop will go onto the surface and it'll spread out as like a really thin coat on the surface.
Oh, okay.
Oh, okay.
If it has low wettability, then it'll beat up into like a spherical ball.
That
Got
makes
it.
sense.
Okay, now I understand. So we want wettability?
I don't necessarily know what we want,
What do we
but
want?
what's going to happen on
Wettability.
granite? I wanted to look at specifically what happens on granite. So I looked at like if granite is wet. I don't know that the word, like, is it wet? What's the word?
Granite can be wet.
Yeah. or like the wettability of granite, I
Yeah.
guess is what I'm trying to say. So what causes wettability and like what influences it is the surface energy, which is, it has to do with like the interaction of molecules and bonds at the surface is kind of complicated. But like when people talk about surface tension in water, they're actually talking about the surface energy between the water and the air.
Okay.
But you can have it with other things like solids and liquids.
Yeah, when you start talking about wettability and surface energy, I'm starting to wonder if you just like were on like a what do they call them? Not astrology, like an astrology shop or something.
Oh,
I got a book about chakra energies.
Like what's the thing where you like put tiny amounts of something in water and dilute it like a bunch? Homeopathy.
Homeopathy, yeah.
Yeah.
The soft sciences, as we call them.
Yes, because they're so wettable.
Homeopathy is about maximizing wettability and surface energy.
This is actually a pretty legitimate scientific
Oh
thing.
no, yeah.
There's
no,
like,
sure.
it got really in depth and kind of confusing when I was looking up things. So I kept it kind of general. But with surface energy or with wettability, they kind of like split it up into two categories for a material. It can be either hydrophilic, which means that the contact angle is less than 90 degrees. So like it's a shallow drop, like droplet. And then hydrophobic, which is the angle is more than 90 degrees. So like it looks like a ball. So low surface energies means it's hydrophobic. So where does granite stand in this scale of wettability? I looked at a bunch of different materials and their surface energies. So a material with high surface energy, they're like metals. So like copper or platinum have really high surface energy at like, it ranged from 1300 to 2600 megajoules per meter squared. That's how surface energy is measured. And then low surface energy are things like plastics. So plastic has around like 32 megajoules per meter squared. And granite is somewhere in the middle. It's on the lower side. So it's at 50 megajoules per megajoules per meter squared. So it's pretty low. And it turns out that water on granite has a contact angle of around like 80 to 90 degrees. So it's like right on the border of hydrophilic and hydrophobic, but it still sort of beads up. It doesn't spread out a lot. So I want to see, like, in the world, are there sites that have just like really, really large slabs of granite? Because like if there's a huge mountain of granite, it's not a mountain anymore. It's just a really big slab.
Right.
So there are a few. The first one I looked at, it actually isn't a mountain. It's in a place called Mount Airy, but that's just the name of the town.
Not to be confusing.
Right.
Yeah. But it's actually a quarry where they like mine granite. So it's actually the largest open-face granite quarry in the world. And it is 60 acres large, which is around 66 football fields.
Wow. Okay.
That's a lot of granite.
Yeah, it's a lot of granite. But we have bigger things too. So
Don't worry, we have bigger granite.
In Georgia, there is Stone Mountain, which is called the largest piece of granite in the world, largest exposed piece of granite in the world. And it's actually a mix of quartz and monzonite.
So they're full of shit.
Quartz, monzonite, and granite. It's a mix of those. So I didn't know exactly what the permeability of the quartz monzonite was, but it's probably low permeability, and it probably still applies to our thing. But this mountain has a 5-mile circumference, which sort of equals around like 1,200 acres, which is 1,400 football fields.
That's bigger.
That's bigger. And then like in Yosemite National Park, there are like a bunch of different granite cliffs and domes and all sorts of stuff. So there's a lot of granite in there.
And it's just like one big granite rock. That's crazy.
Yeah. There's one specific one called El Capitan. It's a cliff. It's made almost entirely of granite.
That's the one. There's that documentary about the guy who climbed it free, or I think it's called Free Solo. Yeah. Who climbed it with no ropes or anything.
Okay, I'm just gonna say that seems crazy to me.
Oh, it's absolutely so. For some context on that, so like that is a thing that people like advanced climbers will do, is climb on their own without like any supports. It's a very, very small like proportion of climbers who do it, apparently. And
Tom Cruise does it in Mission Impossible 2.
This is true. From my understanding from watching that documentary, even that small, like, pretty crazy group of people who do it thought that he was insane for doing it on El Capitan. He thought that they were like, they thought it was like absolutely nuts to do.
I imagine it would be a rapidly shrinking percentage of rock climbers that are climbing without safety equipment.
It's sadly kind of true. Yeah.
However many they started with, I can imagine it being a rapidly shrinking group.
Right.
So yeah, all these granite features exist, and now they're just super flat surfaces. So whenever it rains at one of these surfaces, it's perfectly level. It's not going to drain. The water's not going to drain out. The surface is impermeable, so it's not going to soak through. And water is actually cohesive, which means that like water is attracted to other water. So all the little droplets are going to be attracted to each other. And it has a contact angle of 80 to 90 degrees. So when they form into one blob, it's just going to be a giant orb, giant water orb that's going to have like a 90-degree side to it. And that's what's going to happen. Because like on the mountain, there's like nothing else. It's just granite. It has nowhere to go.
Right.
So it's just going to form into one thing.
Okay.
So that was kind of the end point of my research. It's just like, okay, just random places, there's going to be giant orbs of water, I guess.
There's got to be some physical concept that makes it not a giant globe of water that sits on top of a rock, right? There's a matter of scales.
There might be like cracks in the granite, which it might be able to like drain through, I guess.
I think if you put water on a bunch of water on a granite slab, it doesn't make an infinitely tall 90-degree wall.
Well, no, but it'll be like a hemisphere the entire time. It'll be growing up and out as it grows.
Yeah, it'll be a drop scaled up.
It's like a giant drop of water.
Yeah, we don't have that anywhere in our world right now because we don't have like granite that big.
Gravity's gotta overcome the surface tension pretty quickly, right? Is that the thing that's missing? I don't know.
No, the angle stays the same no matter what.
Marcus's refusal to believe this possibility is amazing.
That was a clip from Absurd Hypotheticals, the podcast where we answer dumb hypothetical questions. For the full episode, click on the link in the description.